Hello, everyone, and thank you for tuning in for today's Tic Tech. Tic Tech is Alif Semiconductor's webinar series made for engineers by engineers. In today's webinar, we will take a closer look at how Grovety has created a more efficient and more accurate wildlife camera using the Alif Ensemble microcontroller. With me, I have Henrik Flodell, Senior Director of Marketing at Alif Semiconductor, and Antony Vasilev, Co-CEO at Grovety.
Hi, Alex. Thank you so much for having us here. And hi, Anthony. I'm very happy that you've been able to join us today. Really looking forward to seeing what you have done with our Ensemble devices and how you put your wildlife camera platform together.
Hi, Henry. Alexander, nice to see you, and thank you for the invitation. I'm looking forward to share our experience.
Anthony, I think it would be helpful if you could start by giving our viewers some background on Grovety.
So Grovety is a team of 16 embedded AI engineers focused on embedded artificial intelligence. So our main domains of expertise are, toolchains, so low-level stack like compilers, tools, SDKs, and IDEs. Here we work with LLVM, TensorFlow Lite, and MicroTV, and MLIR, and other ML frameworks. Plus, we work with the firmware, of course, everything about drivers, board support packages, and working with bare metal, implementation of network protocols, both for wired and wireless connectivity. And of course, applications. Here we work with embedded, with IoT, industrial IoT, and of course, with AI applications. And here we work on neural networks optimization and adoption to the target hardware. So that's in short about us.
Great. And I know our viewers really want to hear the details about what led to Grovety's inspiration for creating the wildlife camera and what exactly the steps you took were to bring that to life.
So, here in Romania, there is a national park, and it was just one day I was working there with my son, and we paid attention on these Persian leopards with the very low population here. And it turned out that the population is very low all over the world. And national park marshals, they are trying, to save this species. And one of the challenges they faced when we just started talking to them with marshals, they said that one of the challenges is detection, taking photos, and identification, because they they even don't know how many leopards are in national park. They said it's around 10, maybe 11, maybe 9, we don't know, because we do not have enough photos, and they don't want to disturb them. They install a lot of camera traps, and so that's the challenge. Mm-hmm. And so we decided to help them by adding some AI into camera traps, because existing camera traps, they produce a huge amount of garbage photos, and they, and it took them a significant time to sort them out, all these photos, and to make the maintenance.
Mm-hmm. I can imagine also that the existing camera traps, like you say, when they essentially trigger every time something moves, and they are out there being battery powered, that becomes an issue. Absolutely. Because you end up with hundreds of pictures of rustling leaves and no shots of what you really wanted before you have to go out and change the battery pack in the thing.
Henrik, it seems you are an expert in camera traps. Okay, so in fact, there are the main challenges here are false positives. You have a lot of false positives, which causes the battery run out, memory is full, tons of trash photos, and all these is caused mainly by hot leaves, for example, or by water drops, or even by the birds. So this all leads to extra efforts for maintenance and a lot of time for sorting. And our idea was to create some kind of the AI module for wildlife trap cameras, and to augment the existing cameras, not to replace them, but just augment, making them kind of smart. And to increase it efficiently, we decided to add this AI and improve the classification accuracy. And this AI module, as we call it, it consists both of the hardware and software components, and provides classification and control functionalities. and external API as well. So this model, it should be connected both with camera and with sensor, because they have the infrared sensor over there. And the firmware should evaluate, both inputs from camera and from sensor, determining the optimal time to initiate computational process. And decisions regarding the activation of continuous capture on the camera should be guided by results gathered, produced by the neural networks, which is based on classifiers.
So essentially, it seems to me that this type of module can then contain different trained models based on exactly what it is that you're looking for. So you can kind of provide one data set if you're looking for a leopard, another one if you're looking for some rare bird, things like that.
Yeah, exactly. So the first step was to gather the data set, and in fact, it wasn't easy because the wildlife photos, the photos of the leopards, they cost a lot, and you cannot. So we signed NDA with National Park. We gathered the data set in 1 month, and only after that we were able to proceed.
And what led you guys to decide to use the Alif Ensemble MCU for this project?
Oh, as I said, so we started investigation research what hardware will fit our objectives and requirements. So in fact, it was the classification. It should be tunable. It should operating time should be very good, and it should be easily integrated into existing solutions and connected with camera traps. And sometimes they even camera traps, they assisted by main cameras which are professional optics, and so it's a system which should be interconnected, and our AI model should be integrated in a very easy way. So plus we had a limitation about the latency, of course, about the size of neural networks and power consumption, about the cost, because usually people don't want to pay a lot for that. They would just to get the feature which will allow them to proceed, but not to overpay for that. And our choice was ARM Ethos-U55 chip, because at the time it was it was new, and we worked already with that chip. It supports popular neural networks. Our model Zoo is well done, and it's rather it has good efficiency and energy and rich ARM ecosystem. All these made us choose ARM, and after that, of course, we choose Alif Ensemble SoC because it has the multi-core architecture, which allowed us, to divide the computational resources. And plus to that, it has very perfect autonomous intelligent power management, which was very useful for us to reduce the power consumption. Here you can see how we created. So here is the SoC. Our work with Alif boards, we aim, to leverage on all these on the free maybe regions inside the SoC. It's always on region. It's for functions they're always powered on and when connected to power source, and high efficiency regions where we perform tasks efficiently to save power and extend battery life, and high performance region which provides us the maximum performance for specific tasks when required to save energy. So these boards have a total 9 power domains, and each of its control are managed by digital logic and software to optimize power efficiency based on the device in a very dynamic manner.
Yeah, so it sounds like you really were drawn to the Alif Ensemble MCU and the Ethos-U55 for the low power consumption and the AI capabilities.
Yeah, exactly.
Henrik, I know we've been doing a lot of benchmarking internally on the Alif Ensemble MCU. Does this line up with what you expected to see?
It does very well, and I'm very happy that you show this slide, because this is essentially one of the kind of key cornerstones of the way that we architected the Ensemble devices. I want to just show another kind of view from this, zooming out a little bit and looking at it big picture. So we set up the family of Ensemble devices essentially a little bit like a layer cake, where we put in at the foundation a highly optimized microcontroller that is intended to handle all the always-on type activities of the device. So we have, of course, a continuum. We have 4 series of our devices. So you can get them with different core configurations. But this specific configuration that we've used in the E1 in terms of how we apply transistors to memories, what type of transistors, how we design interfaces, interface speeds, and things like that, is really all about optimizing for power consumption. So in a dual core configuration where we kind of move this configuration up and use that as the efficient side of the device, you have essentially a part of the device designed for environment sensing. So this can collect all kinds of data from sensors and be the always on part of the system, and do that at a very optimized system power consumption. And then when it detects something that kind of matches a pattern, where now you need to go in and classify the event in more detail. Say, for instance, in a wildlife camera scenario, if you have some sort of PIR sensor or something along those lines to detect movement, now there is movement. What was it that caused the movement? Then you can wake up this high performance side of the device that runs 4 times as fast, essentially, when it comes to machine learning processing. So it will very quickly be able to figure out exactly what it was that caused the movement event. And then you can power that down so it doesn't contribute to the overall system power consumption at all. And this gives you a lot of benefits in these type of systems, because you kind of want to have a baseline power consumption on that always on power domain that is as low as possible. And then when you need something to happen, you want that to happen as quickly as possible, because what you kind of really end up losing out on if you only design a system that, you know, intermittently needs to do a lot of processing with an underpowered microcontroller, is that those processing events take a long time to complete. This is some benchmark data that we've collected for various open source machine learning models, and we've run those trained on open source data sets on our Ensemble devices. So if we look at this image classifier here, for instance, using MobileNet V2, takes over 2 seconds, almost 3 seconds to run that at our Cortex M55 core at 400 megahertz, unless we turn on the acceleration abilities in the device. And this is on a very modern core. If you were to run this on something older like a Cortex M4, these times would go up drastically. But when we can enable our machine learning acceleration capabilities, we can take that down by a factor of over 100. So essentially 20 milliseconds now for this operation. And that means that the energy that you spend to run the inference drops to 0.86 millijoules instead of being up here in the double digits, you know, almost well over 60 millijoules per inference if you run it unaccelerated. So that's a 2 order of magnitude time improvement to actually perform the inference, and also energy improvement by essentially being able to run that workload fast and then go back to the low power state.
That's great, Henrik, and great to see the results actually coming to life with Grovety's demo here. Antony, do you have any sort of prototype that you could show us, or what's the current status with this wildlife camera?
Let me share it with you. Here's our test bed, and that's what we've got right now. So it's a kind of, so it's prototype. We are making tests right now, but now we moved to national park itself, not making it in the office, but in real life. It's working good. Everything is okay. So with leopards, we got very good progress, and they started using 3 our prototypes, and results seems to be very impressive. So for us, they say it's a miracle. And
That's
I said,
awesome.
okay, yeah. So it's a kind of a magic for them, and for us, it's just a perfect technology. I won't just share, guys, with you how what we are doing right now. So we are extending the animals with which we are working with. So right now we are working with all of them. We divided into 2 stages using power management and all the features of Ensemble. So the first stage is, movement detection. Here we decided to use some kind of reservoir computing, which works very good on Ensemble family, plus recursive neural networks. So it's just for detection of movement and to wake up the system. When it wakes up, then we just proceed with the classification using mobile net v2. And now we work with tigers, and we work with leopards, we work with pumas. So that's the next step for us, to add elephants and to add some giraffes maybe.
Mm-hmm.
So we're extending using model zoo, we are extending our zoo.
I was about to say, you're using a model zoo to capture a zoo. That's kind of neat.
Yeah. And plus to that, of course, we are waiting for the next generation of Alif SoCs with even more, with better performance and power consumption, features. So it would be nice to get them and to proceed and to make the not a prototype, but a product.
And Antony, if our viewers wanted to actually work with this model, is that something you plan on releasing to the public?
Yeah, exactly. We are going to release the API. We are going to release everything to share it with manufacturers of camera traps. Hopefully they will be interested and we can, talk. Is that what I can see in the market right now, that we need real use cases of using AI and embedded AI to show the people where is the magic, because when they see it, they are so impressed.
Yeah, absolutely. The AI component certainly seems to be crucial for improving the accuracy.
Absolutely. Alif is doing it absolutely amazing hardware, because I remember when we received the first, generation of these boards, but it was a masterpiece, because my hardware engineer said, wow, that's a masterpiece. That should be something amazing. And really, it is.
That's great to hear.
Great
No, I
feedback.
remember when we started working with you, because we were kind of getting a beta program off the ground, and I remember having conversations with you and the team, and you immediately kind of understood where the architecture was coming from. So yeah, I'm very happy to see this. It's good to see that you've been able to put it to good use, and I hope that we will be able to see these modules in commercial products in the not so distant time frame. Of course, with production ready silicon.
Yeah, and that leads me to my next point, Henrik. I know Antony mentioned he's eager to get the next generation of our boards, which I believe we can provide some update on. Are those available now?
Absolutely, they are. We did a couple of weeks ago our mass market availability announcement, which we're very happy to have arrived at. So we now have fully qualified production ready silicon in stock with our distribution partners. Our main global distribution partner is Aero Electronics for the US and Europe, also in Asia, but in Asia you can also find us with in some local distributors such as Edom. And you'll be able to get our updated development kits from there. We also have dedicated evaluation kits for AI/ML applications that contain camera modules and microphones and sensors and the like, and also the devices themselves. We are now switching up our production capacities for all 4 series of Ensemble, E1, E3, E5, and E7, announcing availability of 2 packages there, both the BGA and the CSP. So,
all right, thank you so much, everyone, for joining us today, and we'll see you next time.
Thank you so much, Alex. Thank you, Antony. It was good chatting with you.
Thank you, Henrik. Thank you, Alex. Yeah, see you.